Alright. Are you ready for this? Because I don't know if I even am. This is a lot. And so anyways, this is how to decode a QR code by hand. Now, I like the QR code better than I like the data matrix code until I try to decode both of them. And the data matrix is a lot easier. The QR code is actually a beast to decode. Anyhow, this is your standard QR code right here. And this one specifically says Robomatics, my YouTube name. So now the first piece you're going to notice about a QR code is these giant black squares here. And those are actually the finder pattern, what your phone or barcode scanner would use to find the QR code with. Now bigger sizes of these have another one that fits right about here. That's a smaller size. These are a 3x3 dot. This one would be a 1x1 with a border around itself as well. But I'm going to show you the basic, very simple, very easy QR code decoding. I might try to do that one later. But anyhow, continuing on. From this corner of this top left box finder pattern to the top right of the lower left finder pattern, man, you gotta think through these things, is the timing. And the timing is the same up here as well between these two. And similarly for your phone or barcode scanner, it would look to see how many black to white changes are between these finder patterns, therefore telling it how big each of these little cells are within the data or the QR code. So let's continue on to the formatting of how the QR code looks. So now this looks crazy, but you only need to remember like one thing when you're looking at this. Of course, we have our finder patterns, and I've marked the timing codes in purple. And let's see, the red here is your error correction, and you got error correction here as well. This is actually a copy from here to here and here to here. And then the green is something called the mask pattern. And to get to that in a minute, finish with this stuff. The yellow is more formatting crap that you don't need to worry about. And then the orange is the space between the finder patterns and the rest of the barcode. I just wanted to fill it in so you didn't get confused when looking at the actual data. And there's this one blue thing here that's like for the error correction stuff. We don't care about it because we're not going to look at the error correction, whatever. And then there is always a black dot right there. I've colored it purple just so they don't get confused again. So, continuing on. The mask is actually very important to decoding a QR code. And so in our QR code, we have this dot, copy over up here is over here. So if we come back up to our real black and white QR code, this is the third dot in, 2 down from the black finder pattern. So our 1, 2, 3 dot in, 2 down right there. So we have black, white, white. So that's why I have dark green, light green, light green. And this indicates our finder pattern. And why is it copied down here? Well, just in case your QR code gets ripped somehow, or torn or messed up or something like that, it has actually 2 spots that your finder can look for to figure out what the pattern is. Now, let's go to Wikipedia here. And let's type in Wikipedia QR code. And let's go there. Now, there is actually quite a few patterns to the QR code as far as masking goes, and I'll show you what that means here in a second once I can find it. Here we are. The masking pattern is this crazy, awful pattern that pretty much inverts the data area of the QR code as so that the data doesn't come across looking blank in some regions or pure black in some regions or even looking like the finder pattern itself. What the mask purpose is to take that data area and just mix it up, and really you're going to figure it out either way because you have the mask pattern to tell you how it was mixed up, so you can demix it up. Now to do this by hand is kind of crazy, so I've pulled together this to show you how that works. So remember now we have a black, then a white for this one. So going to our Finder patterns, we have this guy right here, which is every other line is inverted. And so, knowing that, I have taken every other line, starting at the bottom here, and gone up and inverted, or drawn the mask out as every other line. Now, the only exception to this rule is right here. It's not, every other, then every other, because this is our timing pattern. It just skips over that, and then every other. Okay, so now we got that covered. This is our mask that we're working with. So now how do we take this crazy data here and demask it? Well, if you're going to do it by hand, like I'm trying to teach you, here's how I've done that. What I've got is my mask pattern here, and then I've taken my data and copied it in to the picture that I've drawn so far. So really this is just to ignore, this should actually be purple. Here we are, purple. Don't want to get that confused, that's why I made it purple. So anyways, this is our data, and this is our mask. And superimposing our mask over or underneath our data, really, it comes out looking like this, where the gray is the mask regions that are to be inverted, and the black is the data that is actually there for the QR code. And so what I've done to invert these is basically coming down here. Now this looks crazy, but don't get scared. Is I've taken the gray area here, and I went through to every black area and cleared it out. So if they come across here, we go gray, 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 black. I went gray, 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 white. And, I just went down the line, and every time I saw a black within a gray row, I just inverted it so it disappeared. This is actually supposed to be gray there. Confusing myself. It's terrible. Okay. Continuing on. So now I have every black in a gray area cleared to white. Now I can come through and turn every gray area in these gray rows into black. So now, continuing on down from the row we were at before, here it was gray, I turned it black. This one was gray, I turned it black. This one was gray, I turned it black, and left the whites as whites. So therefore, now we have a unmasked QR code without the mask in it, of course. Alright, so now we have something that we can actually start decoding by hand now that the mask is out of there. And this is why the QR code is so much more awful than the data matrix. By the way, I have videos on the data matrix as well, so check those out too. Let's get to decoding this sucker. Alright, so the first thing we gotta do when decoding this guy, after masking it, is we gotta figure out two things. And those are given to us at the lower left portion of, lower right portion of our barcode. And we have here the encoding, and we have the length. Now, the encoding is going to tell us how the QR code is encoded, be it numeric, alphanumeric, binary, and I think there's like 8 other beyond that different types of crazy encoding. Now, your standard encoding types that you would think of, where it has like capital and lowercase letters, something that would contain like a web page address, that would be binary encoding. And so, if we go back to our good friend Wikipedia here, and we go to encoding modes, we're looking for byte encoding, which is 8 bits per character, as you would figure to be. Alphanumeric, as you would think this would be. Alphanumeric, I think, is, it just gives pretty much only capital letters and some punctuation. So lowercase isn't included with this, so I know it's not going to be alphanumeric. I know it's going to be byte encoding, which is using ASCII. And I was totally wrong. There isn't 8 other. There's like 5 other. And then I'll show you this later. So continuing on here, I'm looking for 0010. Okay, so because 1, 2, 4, 8, thinking through, kind of a binary type pattern, 0010. So if we come back to this guy, 0, 0, actually because it's binary, it starts from this side, 0, 0, 1, 0. So now we know it's byte encoded. Something else to say to that effect, I took this Robomatics barcode here from qrcode.kawa.com, which is a good website you can use to make data matrices or even QR codes and data matrices from. So they use this type of encoding and then use this type of masking. You can have who knows what mask with who knows what encoding on it when you get a barcode. So be careful, because this is only one example of which. Continuing on, this is our length, and Robomatics is 10 characters long, R-O-B-O-M-A-T-I-C-S, Robomatics. So therefore, 8 plus 2 is 10. So I know my length of characters are 10. So now, how do I know how these bytes are flowing? Well, Wikipedia told me. Anyhow, let me show you how they actually flow here. This is kind of a copy over from what Wikipedia already shows somewhere. Forget it. I don't know where they showed it. Anyhow, this is going the encoding 4 bits there. Then I have my length, and then I have my next one, and then this wraps around down, then wraps around, goes up, then down. And then this is special because this is our end character. And this is what I was referring to down with the encoding here. Whereas 000 in the 4-bit chunk means end of message. We already knew it was the end of message because length already told us there was 10. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, end of string. Now what about the rest of this crap that goes up, goes through there, comes back around, goes down, goes through there, comes up, and wraps around, goes around, and down and finishes there? What about the rest of these things? Well, those are the error encoding crap. And you just don't want to mess with the error encoding crap unless you are ridiculously smart and can figure that kind of stuff out. And so I've laid this out in a more kind of easier to read pattern or diagram here, where we have our encoding, our length, the capital R, the O-B-O-M-A-T-I-C-S, the end of message, and then error correction 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Alright, so that's how it's going to look. So how do we get those things? How do I know that this is a capital R and how do I know that this is an O? Well, let me show you how I came to that conclusion. Coming down here to our next position, I'm going to show you how the bits are all laid out. Now the bits in a QR code are just crazy. But if you can, remember this relatively simple zigzag pattern. Let me show you back in Wikipedia. Wikipedia has a great little diagram for this as well, where it shows you that the 1, 2, 3, 4, 5, 6, 7, 8. And that's if the pattern is going upwards. And then here, there it was, that's the thing I was looking for earlier. It shows the wraparound thing that's going through here. So you know which direction each byte is going. You can see here that the, say for their example, the W of www.wikipedia.org is going up. So we know that going up is 1, 2, 3, 4, 5, 6, 7, 8. However, they kind of backwards to, as you would think of a bit in a byte, they say 1 is the most significant bit. So in the byte, 1 would be 128, and then 64, then 32, 16, 8, 4, 2, and 1. So kind of thinking downwards if you can. Starting here at our encoding, we go 8, 4, 2, 1, because it's only 4 bits long. But the next one is 128, 64, 32, 16, 8, 4, 2, 1. So if you can think of this zigzag pattern, right to left, and then continue zigzagging to get to the top. Now the top and the bottom, these sideways bytes, act slightly different, whereas they, if we were to go up the pattern here, 128, 64, 32, 16, 8, 4, 2, 1, and then continuing that same pattern, 128, 64, 32, 16, Now we can think about it as if we are now going left to right, the same zigzag pattern. So we get 8, 4, 2, 1, and then I'm sorry, this is still right to left, isn't it? My mistake. Anyhow, so right to left, 8, 4, 2, 1, 128, 64, 32, 16, 8, 4, 2, 1. You can see it's backwards of the up direction versus the down direction. Really crazy stuff, isn't it? Now you can always reference Wikipedia to, refigure this out, or you can always come back to this video and watch it 100 times. I wouldn't mind that at all. Anyways, continuing, let's figure out what these bytes mean. Now this is where it really comes into play of what's what here. So we know this is our encoding byte, or our encoding bits. It's not a full byte, and this is our length byte. And so the first byte to actually start after that is right here. And so we're looking to see which one of these are filled out, and you can see the dark gray areas here are the actual unmasked bits that we've pulled out. So 64, 16, and 2 equals a total of 82. Now if I go to an ASCII chart, 82 is right here. And 82 coming across my ASCII chart is a capital R. Oh, look at that. We actually have real, what we expect data. Very cool. So now coming over to the next one, I have, let's see, 64, 32, 8, 4, 2, and 1, which in total equals 111. Going to our ASCII chart, 111, stupid thing, get out of there. 111 equals a lowercase o. Oh, holy crap, look at that. That's really sweet. And coming down, now we got our upside down bit pattern, but it functions the exact same way. 64, 32, and 2 equals, in total summed together, 98. Now 98, go right to it, 98 right there in decimal equals an ASCII lowercase b. I think you're getting what's happening here. Now our next byte, again, equals O, and I've kind of found this interesting, how this pattern equals this pattern on its side, which was our first O. And so, the same thing here, 64, 32, 8, 4, 2, 1 equals 111, which equals the ASCII O. And so, continuing on, this is the lower one going sideways. So 64, 32, 8, 4, and 1 equals 109. ASCII that, and 109 equals the lowercase m. So we've actually got Robo M so far. Pretty cool. Now, why am I going through each one of these? Well, because, I want to really drive home the point of how this whole thing works. I mean, it's pretty cool. It's just awful to figure out. Anyways, this byte here, 64, 32, and 1 equals 97, which is an ASCII lowercase a. 64, 32, 16, and 4 is 116 summed together, which is an ASCII T. ASCII T is 116 right there. Very cool. And let's see, coming across the top again, 64, 32, 8, 1 is 105, which is lowercase I. 64, 32, 2, and 1 is 99, which equals lowercase c. And then finally, our last one is 64, 32, 16, 2, and 1, which is 115, which is a lowercase s right there. Very cool. And then finally, our last piece here is the empty 4 bits end thing. I forget what you would call that. The encoding chunk, whatever. That's really to kind of offset the 4 bits that were used here. I'm sure if this thing were longer, like if I had more in here, it might take up some more in the error correction, just maybe less. And the encoding would then shift from here. You would have an 8-bit section here, and then it would come up, and wherever it would end, you would have, say, another 8-bit chunk here, and say this guy was your end of string, if you will. And then your error correction would start right here. So there we are. That is decoding a QR code by hand. So you can have fun with that, decoding it by hand just because you wanted to learn how, or you can make the next awesome program and make tons of money. Just after you make tons of money, remember your old pal Robomax and come watch his videos a whole bunch of times so I can get a whole bunch of quarters of pennies. Anyways, have fun with that.